Good afternoon. I hope you had some lunch and sleepy, yes? Hopefully not. Otherwise, this will put you to sleep. You're okay. Um, so, hi, everybody. Good afternoon. Welcome to my talk, and thank you for being here. We're going to talk about post-modularization today. So basically, you have your modules. What do you do with them? To start with, before we do our talk, just a little bit about me. I'm Kinara. I love sweets, so if there's candy somewhere, I'm there. I also have a 3D printer, so if you want to talk about 3D printing, you know where I am after the talk. I currently am an Android developer at IOKey, which is in Frankfurt. We're a sustainable mobility company. A lot of what I'm going to talk about today is something that we implement in our apps. We release over 100 apps every sprint, so this is a really large undertaking in terms of white labeling. And so we have over 100 modules. This is what we're doing with our modules, and it's working for us, so I thought it might be helpful. OK, so what are we going to talk about today? I'm not going to talk a lot about why we need modularization. You're here because you already have modules in your app. You want to know how to structure them better. So even if you're looking for an actual exact number about how many modules there should be in your app, I don't have an exact answer. But there are certain things you can do to improve how you can structure these modules, how to make sure your developers have better access, how to make sure there's proper ownership of these modules, and structure them better so that your developers can access them faster, better, in a way that works for you. Next, we're going to talk about what types of modularization they are. Why we're doing this is to make sure we can actually group these modules together before we structure them. And then we're going to talk about structuring modules. We're going to use what we talked about logic in terms of logic with types of modularization to nest them together and make sure that we can access these better. Last, we'll also talk about access, ownership, tools, and resources to make sure we enforce whatever the rules that we've declared while structuring these modules. First, we'll go quickly through this. Why do we even have modules? The whole reason we started with this is to make sure we don't have a monolithic code base, right? To make sure that we can build faster, something that we started with in Java we don't want anymore. So the whole reason we're doing this modularization to make sure there's a separation of concerns, especially with testing. You don't want to mock the entire universe before you're testing something. You want to make sure you have very specific classes that you're maybe creating objects of without mocking to make sure that your modules are isolated in their space, right? So we're already impressed with modules. So we create a module, then we say, oh, this is working great. So we create more modules, and then some more modules. So we already have a lot of modules. Just before we go ahead, can someone throw out a number? How many modules do you have in the app you're working on at the moment? Anybody? Just throw out a number. Sorry? 10, OK. 817, OK. That's definitely a number. Please talk to me after the talk. So at this moment, the app that I'm working on has over 150 modules. Scrolling through them, trying to remember whether compose comes after core is, you're working your brain into how alphabetical order works. We don't want that. So how many is too many? What you're really thinking about in terms of modules is the reusability that you want to have. You want to make sure that when we create modules, why do we actually create them? If you have multiple modules that have the same code being reused over and over again, we create a module. And then we have dependency management, because we have a new module that needs to have a dependency on the old module. And you really have to make sure that these dependency graphs are not too deep. If you have 10 in a line of your dependency graph tree, then what real use are these modules? They're depending on each other. They're rebuilding every time you want to do something. You're not really achieving what you're going for in terms of modularization, right? You want to make sure it's somewhat shallow in terms of the graph itself. You want to make sure your testing is isolated, compact. You want to make sure your developers are not hindered by how many modules you have. It has to add to the experience. You don't want them to go for something, and then they find out, no, it's in the next module, and then in the next module. You want to look at what type of project complexity you have, team size and structure, and you know why you're here. So what do we talk about? In terms of types of modularization, I like to put them in these these basic sort of buckets. We have the library modules, which is logic without any of the UI, right? We're talking about API calls, we're talking about networking, logging, errors, if you're catching errors right off the bat when you're calling your API. Then we have our feature modules, right? This is the isolated logic that we have with the UI. This is where you have your state machine. This is where you have all your business logic. You're isolating features based on what they're doing for your user. And then you have your domain models, which is basically data classes, right? But then you're wondering, you already said that when I said library, right? Why is this different? It's different because this is just data classes. This is the difference between the data and where you're using this data, which is in the libraries that you already have, right? And then if you have multi-platform projects, you have your own platform modules, or if you're doing dynamic features, you have modules for those separately so that they can be bundled in or bundled out depending on how you're doing your app. So, OK, so right now, this is what we talked about, right? We have feature login phone and feature login email, for example. You have some things in common. You put that into a common lib implementation, and then these two modules have a dependency on the common lib implementation module, right? So this is something that we already do. This is an obvious way to implement it, right? How can we do this better in terms of modules? We can define an interface module that has an API. So for example, your login phone and login email has the same API, for example, just to log in, right? So you have that API call, just the API, not the implementation of the API call, in the common lib interface, right? So you have the interface there, and then the actual implementation goes into the common lib implementation, which is the little green cake. So what does this do? This improves abstraction between your feature and your library modules. But how does this help? Whereas just adding an extra module. Is this really useful? So how is this useful? The way that we look at this is that if, for example, you have multiple implementations of the same interface. So you have your API, right? But you're calling two different things. For example, if you have a marketing library, and one client wants, I don't know, in terms of analytics, one client wants Facebook, one client wants Firebase Analytics, one wants Google Analytics. How do you implement the exact same thing? Do you want to do like an if-then statement, which is what you would normally do, right? You have a when statement. You say, if this is this client, this flavor, you want to go ahead and do this particular implementation. What happens is in this is that your dependencies that you're adding, you'll add all of your dependencies. So a user who does not really care about having Google Analytics is still getting that dependency into their app. You're bundling in way more than you need to bundle in. So how do we tackle this? So in this case, this is where the interface comes to use. You still have your lib feature that you're using this in. You're implementing the interface, and the interface is going to find which implementation it needs. For example, default implementation can be a co-op in the no-op, I mean, in the sense that you don't have to implement anything if it doesn't need anything. How do we do this? So we're going to have a minimal set of classes, right, that allow us to differentiate between the feature implementation and an interface. For example, I want the same call to show two different fragments, right? For example, someone wants to show something in a completely different UI compared to the other user. But it uses the same interface, right? We still have the same login email, but someone wants to see the email text box at the top of the screen, another at the bottom. How do you do this? You create a fragment factory. This is to make sure that we have an interface which is being implemented by other classes. And then we actually have to tell this interface how to find the class that implements this. This is the glue code that we have. So what is this glue code? We're creating the feature fragment, and we're going to find out which implementation to use, right? So normally we would do reflection. We would go ahead and say this class as class A or class B, and then implement whatever we need from this class. But here, what we do is use a service loader pattern, which is questionable. But in this case, it kind of works because it doesn't know which implementation it is. It finds out at runtime. And how does service locator help? It instantiates these implementations of a known interface without knowing about the implementation at all. So this interface is completely abstracted out from the implementation. So think of this as with Dagger. It creates a class, it's an application scope, and it can be accessed wherever you need it throughout the application. But in this case, it's only being accessed by your interface. So how do you do this? So we have our interface. We already have it. We told the interface how to find our new fragment factory, but we have to implement this now. How do we do this? We create a meta and services file, right? This file is named after the fully qualified name of the interface. So if you look at the name of the interface, it's the feature fragment factory. We've given it where to find the interface itself. And then inside this file, we'll tell it where to find the implementation, which is the feature fragment up at the top, right? And so now it knows what the interface is. It knows where we're implementing it. Now we have to actually implement it. How do we do this? In this case, we have the generic implementation here, right? So we are extending feature fragment factory, and then we're implementing all of the arguments that we defined in our initial interface, right? So in this case, you can do this in every single implementation you have, multiple implementations. You can do nothing. You can do different analytics. What happens in this case is that depending on the flavor, for example, if I say my flavor is AMDC24, in this case, to that specific implementation, I'm adding the module that we have for opt-in, right? Otherwise, I would use the no-op module. That way, you're not adding dependencies that you don't need in your module. You're reducing what kind of overload that each of your modules has, especially if it's a feature with multiple implementations. OK, so now we've talked about what kind of modules we can have. We've talked about interface modules, which improve how you can work on different implementations of the same feature. Now, how do we structure them? We usually think of them in a linear way, right? You have all of them up to down. You're scrolling through them every time you need to find something. But package names are interesting here. If we have the package names already defined in a way that tells you what kind of module they are, for example, we have the feature modules, we have the lib modules, we have the domain modules here. But they're still in a linear fashion. We've named them correctly, but we're still accessing them the same way that we did before. They're just grouped together. So we could actually nest these, right? We already have a bunch of, you're thinking maybe we already have so many folders in our Android projects. Do we really need to add more? But when you think about it, if you only have 3 folders to work with in the beginning, you have feature, lib, and domain, and you know what you're looking for, it becomes much easier to access it. But you have the same package name still. So you don't really have to worry about refactoring your entire app to make sure you can nest something. You already have this in your package. Key is to group them logically, right? This is why we talked about what kind of types they are. You don't have to do them the way that I mentioned it. You can also group by features, for example, or whatever different thing that your team has. Think about what your developers will work on. You think about features and libraries in the sense that which developers will work on what project, right? What logic really works for your team. And then using this structured approach, you have a code base that's easier to navigate. You don't have to look at them in alphabetical order. It's like having a well-organized workshop. You know which box to pull to find out what you want. So you have this nested thing. We've talked about what kind of modules. We've put them into nested things. How useful is it really, other than navigation, which is useful, but not that useful? How do we do them? How do we do better with this? Right? We've interfaced them, we've structured them, nested them. Library access really has to be well-defined in terms of dependency management, right? Think of it as a library. If you're a librarian who is responsible for keeping things in order, you want to define which librarian is specifically responsible for which part of this library, right? You want each shelf defined in that sense. You want developers to be notified every time something changes in a folder. For example, you have somebody really good with libraries. You want that particular developer to be notified every time something changes in that module, right? How do you do that? You also have like these certain things in apps. I mean, I know we talk about clean code, but there's always some workaround somewhere, and you do not want to touch that minefield, right? You touch it, it goes boom. So you don't want that. How do you get rid of that? You want to make sure you have a code owner's file. This is something that's worked for us really well, especially with GitHub. In case you define, so for example, with Gradle files, you have the star.gradle. Every time some Gradle file is changed, and you define who is the owner of that file, they get notified on GitHub, right? They get added to the review pile. That way, you know nothing is going through the cracks, especially if you have a large team and you've added reviewers already. They're taking a look at it, and they know it works, but they don't know if they've missed something, right? We always have a little workaround somewhere that will crash if you don't look at it. So how do you make sure that happens? So in this case, the file order is really important. The more specific you get, the further down you go, it takes precedence, right? That way, we clearly define who can oversee what part of the code. And it automatically requests review whenever a PR opens. Okay, so just a little question to break up the monotony. So in this case, the last but one, the feature/1, it's the feature one team, right? But who else do you think has access to this in this co-owners file? We have a code owners file. We're clearly defining who has access to what. The first one is the folder. The second one is whoever has access to it. So who do you think has access to feature one? Yes. Feel free to guess if that's more helpful. Yes. Sorry? Just feature one? Feature and feature one, okay. Anyone else? Sorry? I can't hear you. Core Android team, okay. Core Android team too. Yes? Anybody else? Anybody who thinks just the feature one team? No? Nobody? Which is actually the right answer. Because the way that this works is that the feature team, because we've mentioned that the feature folder has access, will have access to everything except the one folder. So because we've clearly defined what a specific subfolder has, which developer has access to that specific subfolder, they're the one in ownership. So everything else is whatever's the parent folder of it. So this is a really good way to define something where in the mid corner of your code base that you want this one person to take a look at if it ever changes. Right? So something that we also do is set up, we have a lot of modules, right? And we want to make sure certain developers don't need to compile every single thing. What we do, I mean, kind of weird, but we publish all of our modules to Nexus, and then we use that to build our app, right? Especially if there is a developer who's working on the app itself, especially with white labeling that we do, they usually change how Firebase is accessed, keys, colors, strings, lots of themes, but they don't really have access to the modules themselves. So they don't need to build the modules every time they run an app. They can just use these Nexus dependencies to make sure it runs way faster, especially because we release almost 100 apps every 2 weeks. We want to make sure that we don't spend time building the app every single time when we know some of these modules are repeated. The way to bundle them together is to use them as complete dependencies so that we don't have to build them each time. Kind of cool, right? And we usually use this even when we're working, because in this way, we're actually reducing the amount of time it takes to build our app, especially if we're changing something and we know nothing else will be affected. OK, important tools and resources that we use. The first one that we use is a module graph assertion library. We know that feature modules should not depend on other feature modules. A library module should not depend on feature modules. But who is really enforcing this? How many of us really go through build.gradle files before in a PR, right? Especially if you're creating a module. We think of them as boilerplate for the most part. So we really want to make sure we're doing the right thing with what kind of dependency you want. Don't want circular dependencies. You don't want too long a dependency graph, especially with Murphy's law of dependencies, right? If it can access it, it will access it. We don't want that to happen. So we want to make sure that our Gradle plugin keeps our modules graph healthy, clean, and why does this module dependency structure matter? I mean, I keep saying you want to keep it shallow, not deep, right? Why do we want this? Because build speeds are kind of very dependent on the structure of your module graph, right? This tree itself is, if it becomes a list-like structure where you're just continuously depending on something, you need to actually separate them into logical units and enforce these dependencies, right? If it becomes very difficult later on to make sure these problematic dependencies get better. If you're not enforcing them, then you have lots of undesirable dependencies that we don't want. And we all have custom rules in our code bases, right? Something that we did as a workaround, something that we did just because we needed a certain something at some point. We want to enforce this. So this is a good way to do that. One more thing that we use, this is more hardcore than the previous one, is to make sure that the dependency analysis tool gives you advice. So it tells you this is absolutely wrong, right? Number one, it tells you which dependencies are unused, especially if you're removing code and then you don't realize you don't need the dependency anymore. Number two, transitive dependencies, right? You can use these dependencies directly. You don't have to go through another module to get these dependencies, and you don't realize that happens. Number two. Number three, if you're using the wrong configuration. For example, using API instead of implementation, implementation instead of compile only, or compile only instead of API, you want to make sure you get this right. Number four, if it is it can be a JVM module, right? If you're not using Compose, if you're not using any Android library, this can very easily be a Java module. So you can, or a Kotlin module for that matter. You don't really need everything to be an Android module itself. Also something that this can help with, I would really recommend this library as something to use. It really helps with our build speed and the way that we have dependencies structured. OK, most importantly, your team is your friend. You have to adapt, revise. Feedback from your team is really important. Best practices are great. But what really works for your team is something that you have to decide for yourself. Revising is really important. I think last year we went through 4 different ways of looking at our modules before we decided on the ones that we're using now. And we are looking forward to doing more revisions, right? We're always looking for some way to access better, develop better, get faster build speed, especially with Android. So yeah, best practices change with time. What works for you is the most important. The best is second. Make sure it's right for your team, and ask for feedback. So yeah, that's what I have for you today. Thank you so much for coming to the talk and listening. Thank you.